I just want to make things bigger, but I guess I can't. Okay. So lacking the ability to make some of the other things larger, you may if you're not on the Discord stream, I would really recommend it because it's really hard to see on this projector. But over on the left, there is what we call the project pane. The project pane is how you get to all of the files in your project. So we're dealing with a brand new project here, and that means over on the right we have a few things. Okay, so at the very top level, you'll see that there's basically two folders listed. There's an app and there is a Gradle Scripts. Everybody see that? So the app is where the main part of your code is. That's where we'll spend most of the time. The Gradle scripts are the scripts that are being used to actually build your application. Okay, those are the scripts that are actually used to build your application. There's a few different scripts in here. The main two that we care about are both of them here named Build Gradle. They're in two different folders, which is why they're allowed to be the same name, and they do contain different bits of code. We'll talk about those more later. But that's what's going on there. All of those files are related to building your project. They do come in occasionally. So for instance, if you wanted to bring in another dependency, change some of the settings that we change when we set when we created the project. So for instance, if we wanted to go into the second one, you can see that it says their minimum SDK is 24. So we could go into this file and change that if we decided we wanted to target a different KPI level range. Yeah.
The way you're streaming it isn't a different view.
Oh. I'm not sure how that happened, but I will fix that. Okay. Can you see it now? Okay, good. So if I wanted to, for instance, change this to 21, okay, one thing to mention about these Gradle files is the changes here don't apply immediately. So in order to apply these changes, you have to hit the sync button, which is up here on the top right. It kind of looks like an elephant with a little blue arrow. That is the sync button up here. It's the fourth or fifth one from the right is sync project. Okay. If you hit that, then it will rebuild the project using the changes that you made. I'm not going to do that. I'm going to go back to 24, and that's going to mean I don't need to change it. But there's a number of settings here that you can go in and change. So version numbers, etc. These two versions here, version code and version name, are the actual version of your application itself. Right. So if I wanted to ship it out and then ship up an update to it, etc., then I would need to get in here and change those things. Okay, so let's go up to the app folder. Now that we've kind of looked at the Gradle files, and close those. Okay. So under the application, there are three folders there. There's a folder for your manifest, there's a folder for your Java code, and there's a folder for resources. Okay, so let's start from the top, the manifest. Okay, so the manifest is simply just an XML file. XML file that your application will only ever have one of these, but it is required, right? It's actually the first thing that Java reads or Android reads when it runs your application. This is the first place it looks. Because it tells you what's in your package, what's in the application, what parts are in there. So things like what activities are in there, what services, what broadcast receivers, etc., 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 etc. It's really a manifest or an inventory of everything that's in there and large application-wide settings. So if there's anything you need to change that's affecting the entire application, this is largely the place you're going to go do. Okay, so that manifest, it should kind of ring a bell with the manifest.json that we did with the PWAs. that manifest.json serves the same purpose as this. And it serves as giving that metadata as well as other things. Now, I would argue that there's a lot more in here than there is in the manifest.json for a PWA. But that's kind of that same idea. Okay, so the manifest file is there first. A few things we do need to look at. You'll see up in the top, the first line. This is an XML file. So the first line of this is that XML version 1 encoding UTF-8. Okay, that tells the compiler, that tells whoever's reading this file that this is an XML file that is version 1 and how it's encoded. We won't change that line at all. Don't get rid of that line, but it won't need to change. Every XML file that you create through Android Studio will automatically add that declaration. You just leave it alone and it'll be fine. There's no reason that we need to make that different than what it is, but that's what that's about. Okay. Next up, we have the manifest tag. So we have an open tag called manifest. In XML, you can actually basically come up with any name tags you want. There's all of the standard tags that you have in HTML. None of those exist. You just come up with tags as you need them. So largely they're driven by whatever you're trying to build. Okay, so Android, because they're using XML, they've defined some standard tags that they use with their manifest file and other files, other sorts of resource files that we work with. So the head tag here has to be manifest. XML namespace is what this part stands for. XML namespace there. So it's declaring a namespace called Android, and it's telling the reader, where do I find the instructions, where do I find the specification of all of those tags and attributes that fall under the Android namespace. Okay, so that's defining what we generally call it like an XML schema. Okay, so that namespace declares Android, which is where you see Android : a bunch down later, right? That's what makes Android : work later in the file. Again, this is automatically created for us. We usually don't need to do too much with it, but if you get rid of this one line of code, this line 3, everything breaks. Just so you're aware. So don't break it. Here, this is the name of our package. Okay, that's the name that we typed in. Fair forewarning, this is not the only place that a package name occurs. In fact, the package name is going to occur at the moment. I believe it's in about 5 different files is where you'll find the package name. In addition to every new file we create will also contain the package name. Every new Java file that we create and every new XML file. So it's worth mentioning, it is possible to come back later and change that package name. It's not an easy process, and I would really recommend avoiding it where you can. Okay, so it's oftentimes can be less work to create a brand new project and bring the code over than to try and change the package name of an existing project. Okay, it's not an easy thing to do. There's not an easy one-click refactor anywhere in Android Studio. If you look at their own documentation, they say, go change this and this and this and this. That's what Android Studio will tell you to do. So that's that there. Next up, we have the application. So that declares that, hey, this is an Android application. Inside of that application, we've got an activity. An activity is basically a screen. Anytime we want to add a new screen to our application, not only do we have to create the application file itself, the activity file itself, we also have to add an activity tag to the manifest. The good news is there's a way that you can go through creating activities. If you do it right, it will automatically add that to the manifest. But if you just go through and say create a Java class, it won't automatically add it to the manifest. You'll have to do it manually. That's a big forewarning, because I always have students going through the first test or two and things are not working. It's not finding the activity because it's not in the manifest. So do keep that in mind. This manifest is really, really, really important. Okay. This is something that we'll be expounding on as we go on. But that's the starting point. Next up, let's look at Java. So under Java, you should see that there's 3 different folders. Okay. There are actually a lot more folders than they look at like, because actually think of every dot in that path as a slash. So those are actually nested folders. Okay, so it's actually edu / Ranken / Paul Smith. Those are actually nested folders there. But these are what we call packages, right? So in the Java world, these are packages. In the terminology of IntelliJ, these 3 different folders are also source sets. Okay, so the top one is our actual code. Okay, this top one is the actual code that we will be writing. The second one, you'll see at the end of it is say parentheses Android test. That is what we call a UI test. It is a test, an automated test that will actually run on an Android device and tell you whether it passed or failed. Okay, and you can actually write multiple tests and create your own tests if you want to go that way. Third up is it says just test. These are for unit tests. These are for automated unit tests. So those are what those other 2 source sets are for. I am not in this course planning to talk about that automated testing portion of it. It's really beyond the scope and doesn't. My previous attempts to teach it in the semester have found that it doesn't really fit with everything else that we have to cover, so I'm not going to be really talking about those. But that's what that's about. So for unit tests and Android tests, that's where those are fitting in. Okay. So all of the real code lives up here. Okay. And so right now the only class that we have is this main activity class. Okay. That's the only class that was created when we started a new activity, a new app with the empty activity. If we'd started this application with no activities, we wouldn't even have this file here. This only happened here because we said, let's start it with an empty activity. So let me zoom in a little bit. There it goes. So first up, we have at the top of the file, we have this package, right? So that says where it lives. Every Java source file that you have, assuming you're using packages, will have a package declaration as the first line. And it does need to be the first line. You can't move that package declaration. If you move it anywhere else other than the first line, then Java will say, oh, there's a problem here, this won't compile. Okay, so it needs to be there and it needs to be right. Okay. Also means if you move the folder structure around, then you have to remember to update the packages as well. The import statements, these are then usually collapsed by default in Android Studio and IntelliJ, so it won't show you them, but if I hit the plus, then I can see them here. So we can see that we're importing code from app-compat activity, and we're importing something from bundle. Both of those are being brought in by default because we are extending the app-compat activity. This is a subclass of app-compat activity, and it's accepting a bundle as an argument to this function. So because of that, it needs those 2 imports out of the box. Okay. So we've got a class called main activity. Your application should always have a class main activity. I don't care what you're building. I don't care how complicated it is and how many other things it has. Every Android application should have a main activity. Okay. The main activity is the first activity that your user sees and should always be the first activity that the user sees. So what happens is when the user taps your icon, say on their home screen or wherever they have it from their launcher, it's going to launch into the main activity, at least the first time that they start your app. It may or may not start there on later runs, but the first time it will always start on main activity. It's like your home screen. Okay. Now, you can put logic in here that says, okay, well, if they're already logged in, if they've already had a session or such and such, then we can redirect them immediately to another screen, but they always have to come to the screen to begin with. Okay, just so we're clear on that. They always have to come to the screen first. There's no way to change that or necessarily bypass that. All right, this class has a single method. It's called onCreate. You can see that it's marked protected. Protected means that it can only be accessed by itself or any children, any child classes of itself. Okay. Void means it doesn't return anything, and then this is what we call override annotation. Says that it's overriding a method in the base class, right? So there is an onCreate method in app compat activity, and we're extending it. We're adding our own logic to it. But anytime we override a method, we need to remember to first let the base version run. So the base version, we say super, which is our parent class. Super refers to the parent class. I say call its version of onCreate, pass in this bundle, let it do its thing, let it go through its onCreate process, and then I'll come back and do my thing, right? And so my thing right now is pretty simple. I'm saying set content view, which is saying, okay, I want to show something on screen. And what I want to show on screen, what is the main content of this activity, is whatever is in this layout file. So r.layout.activity.name refers to a layout XML file. We'll look at that here in a minute. Okay. So that's saying, hey, there's an XML file that defines this layout. Show that here. Whatever's in that layout, just expand that, inflate it, put it on screen. Cool?
So quick question. So within the onCreate, you're importing a bundle called save instance state. Is that one, or is that two separate things?
Where are you looking at? Are you looking at this line?
Yeah, so it's a bundle called save instance state.
Yeah, it's
okay.
It's type bundle,
Okay.
and the name of that variable is save instance state. Okay. Yeah. So the thing on the right is the name of the variable. The thing on the left is the type of the variable. Okay. Next up, let's look at the res folder. So we've looked at what's in Java. We've looked at the manifest. I'm going to go down to res, which is short for resources. So res is where our resources live. You'll see there's a few different folders here, and basically the way the Android Studio groups these by default is groups them by the kind of resource they are. So what type of resource are they? Is worth mentioning when it comes to the code, when it comes to what's up here in Java, it is actually possible to add additional folders and packages and organize it in whatever way you want. We don't have that flexibility with resources. Resources actually have to be structured the way that Android Studio says they have to be structured. I wish there was a way to change that. I wish there was a way to add additional folders, but there isn't, and there's never been. So just a heads up with that. One of the things that means is these projects get larger. You're going to have a lot of files under layout. You're going to have a lot of files under drawable, etc. Keeping good naming in there will help to keep it from becoming a mess. So it's really important to pay attention to some naming schemes so that you can keep track of the files that you've created and where they are and what they're named, etc. Okay, so let's look at what's under drawable. Okay, so under drawable is two files. You can see that they're XML files. When I click on the first one, you see IC Launcher background is kind of this gridded background texture. Look at foreground, and you can see it. This is Android logo. Okay, both of these two images are everything under drawable is basically an image, whether vector or PNG or whatever it may be. but these are being put together to make our launcher icon. So this is the foreground of our launcher icon, and this is the background of our launcher icon. You'll notice both of those are XML files. What that means is both of those are basically SVG, right? That's actually the format, roughly speaking, that these are stored in. Everybody good with that? It's not exactly the same. The container, the outer element is different from an SVG, but they follow almost the exact same syntax as SVG files. Next up, let's look at layout. Under layout, there is a single layout. This is where we're going to spend a lot of our time. So our layout is how we determine where things are on the screen, how we position them, how we say, hey, I want more widgets and I need to position this above that and this next to that. The layout is how we're going to start by putting things on the screen. We have to put those layouts first in place before we can start coding. You can't really start coding until you have a layout and components to work with. So the development paradigm with Android is always you build the layout first and the Java code second. You can iterate and go back and forth. You can make changes to the XML, come back, make changes to the Java code, and vice versa, jump back and forth. But you always have to start really in the XML world first. Okay. So that's the designer that we're going to look at. I'll take a quick look. We'll come back to here because I want to show you some more things here. But before I go all too deep in there, just over on the top right, you'll see there's a design, a split, and a code option. I'm going to flip over to that code side and zoom in. This is the code for that screen, right? So you can see all of your layouts are going to be stored and written as XML files. Okay. So on the outside is what kind of layout are you using? So here you can see we're using a constraint layout, and we can see inside of that constraint layout is a single text view. Text view is basically a label. So there's a single label, single bit of text inside of this label. And actually, if you looked at the designer, you saw it was centered on the screen. Okay? So that's all we're starting with. That's all we're starting with here. Is we've got a constraint layout and we've got a text view inside. Looking under Bitmap, you'll find there's some additional files related to the launcher icon as well. So there's a series of WebPs in here, and you can see that there is a IC launcher round, which gives us this, and there's a regular IC launcher that gives us this. Some Android devices use round launcher icons, some use square, which means that for modern app development, you actually have to provide both. You have to provide both a square icon as well as a round icon. These, you may notice, seem to look the same. They could have actually used the same icon for both of these. And they're also, neither of them are necessarily round or square, because what it's actually doing when it runs, it cuts out part of the edge. So on the ones where it wants round icons, it will cut it out and make a round border. And the ones that want a square will cut it out and make a square rectangular border. Okay. So that's what those are about. Both the stuff under Bitmap is also images. I personally have been doing Android for years. I still don't understand the difference between Bitmap and Drawable, to be perfectly honest. Most of the time, things go under Drawable. The only few things that I've seen under Bitmap that I'm aware of are those launcher icon things. So I'm not entirely clear what the distinction between those two folders is. Under values is another kind of interesting area. So everything under values is largely not just like, here's a single resource, here's a collection of resources. So for instance, in colors.xml contains a palette of colors. Okay, so you can see that there's a resource tag on the outside, color for each of these colors. Each of these colors is being given a name and then a hexadecimal value, right? So we have, in this case, we have what, like 8 different colors that is being used as the palette for this application. If we wanted to later come in and change it to our own palette, well, we need to go back in here and put in our own color palette. We'll do that later. So we've got names and we've got colors. Okay. Strings is the next file. This one we'll be touching all semester long. So this is where you put any pieces of text that are in your application that the user is going to see. Every single piece of text that the user is going to see must be in strings XML. It's actually one of those things I grade for. Okay. Make sure that you're very diligent about that. The reason that we do this, the reason that we put all of our text here, is it enables us to translate this app into other languages. Okay, so what happens is we're going to start with our first versions of strings XML is all going to be in English. And then when I want to translate it to Spanish, actually it's really easy. I just make a strings XML that's in Spanish, where all the strings are in Spanish. And assuming I've been diligent and made sure that all of my strings, all my user visible strings are here, that's all I got to do. Is just drop into another strings XML, and voila, it's in a new language, right? So that's what this is about. Strings XML is all around doing translations. So very clear with that? It's going to feel like a lot of extra work, because every time we have to write a string, we're going to have to go through this process we call extract to string resource. Basically, you're going to right-click the string, tell it to extract, and it's going to put it into here instead of where you were previously looking at it.
So how does it work again whenever you're translating to a different language?
So whenever we're translating to a different language, we're going to take this, right, which is English.
Mm-hmm.
We're going to make a copy of it, and then that's basically because we're going to translate all the strings in there to be Spanish.
Like you gotta just basically translate on your own, like go to like Google Translator and do it like that?
Well, so that's a good question. So there's a few different ways to do that. We'll talk about that maybe later. But you could go to Google Translate, feed things in, that will give you a version. That's what we're going to do in class. It's not going to give you a very good translation, but it will give you a translation, right? What most companies do is they actually go out and hire somebody to do the translation. Usually most companies will go out and actually pay somebody to, okay, here's my strings XML, give me a version that's in Spanish, give me a version that's in Japanese, give me a version that's in German, etc., etc., etc. So that's usually a service that most companies contract out. Okay? But
I just wasn't sure if like there was like a setting reset, like, well, I want it in Spanish, and it just doesn't.
yeah, it's not that simple. It's not that simple.
Yeah.
It's usually like, hey, here we want to get this into Spanish. Here's a few $1,000s to get it into Spanish, and then they'll do their work. They'll give you back this file, and then you'll have some back and forth, right? Where there's issues, and you'll find that like, oh, we needed to translate this, right? Which we forgot to translate. So, but that's what this was all about, right? Okay. Next up, themes. So there's what looks like a folder here. It's not exactly a folder, but there's 2 variations of themes XML. This first variation that we're seeing, this is the light color, the day theme, and the second one is the night theme. The way this works is if the user's Android phone is in light mode, which yours are by default, it will be using the light theme. If you switch the phone as a whole into dark mode, it will use the second variation, which is the night theme. Cool. So that's kind of an overview of the files that are already there. To help you out, only some of those files we care about right today, this week. Okay. So the only 2 files that we really, well, 3 files that we care about today is going to be the main activity.java, main activity Java file, the activity main XML file, and strings XML. The rest of those files will come back to later, okay? But those are the three that you really want to focus on today. Cool? But at least now you know where they are. So we've got an empty project that we started. Maybe, and now we know kind of where things are. Let's talk about how we actually get this running. Okay. So when you look up at the top, you're going to see that there is a dropdown, right? You see there's two dropdowns. There's a little hammer here for build. That's going to build your code. The next icon is this dropdown that just says app. That would be a dropdown you would use if you were testing things, if you're trying to run some of those automated testing. So we're going to leave that alone. This one is our biggest friend. We're spending a lot of time with this dropdown here. This dropdown tells you what device do I want to run my application on. Okay. So based on what you picked there, is going to change which emulator or which physical device that your code runs on. If it says nothing, when you hit go, nothing's going to happen. Okay, so oftentimes things can happen if your device gets disconnected, boot turns off, etc. That may automatically change. So do definitely keep an eye on to make sure that it's deploying to the device you want to deploy to. It's very easy to make mistakes with that. Okay, so I have some devices in here already, but you probably do not, right? Just checking, does anybody see any options in that dropdown? All right, so Brandon, what do you have in that dropdown? What's one of the things you have in that dropdown? Okay. Does anybody have anything else? Same thing? Does anybody have something different?
I have something different, but that's only because I put it there.
Okay. Okay. So depending on how you went through the installer, sometimes the installer creates emulators for you, and sometimes it does not. Some of you have already worked together with to create an emulator, so that's why you have API 30 already. Okay, Nexus S API 30. For everybody else, I still need to make sure that everybody's in the same place. Okay, so what I'm going to do is I'm going to go down to AVD Manager here. That's going to get me here. This is the Android Virtual Device Manager. Okay, this dialog is your best friend. It's how you create and modify and delete emulators. Okay. I, as you can see, already have a few, right? Because I've already taught this course, I've already done some things. So what I'm going to do, though, is I'm going to go ahead and go here and delete. And I'm going to actually just delete all of the emulators that I have. If you have any emulators outside of that Nexus S30, which I helped you create, please delete all of those additional emulators now. So it should either look like this, where there's none, or there should be the one Nexus S30. Okay, so you're back to here. So everything goes down here. Okay, good. That's what I'm going to do. Okay. Intersect. We have the one. We have the one. Okay. So we're going to go how to create this Nexus, the one that everybody has to make sure everybody's in the same place. So we're going to go create virtual device. We're going to look under hardware. This is kind of going to give you the dimensions of the device. And I'm going to look for the device Nexus S. Again, if you have this, you don't need to follow through this again. But we're going to go through Nexus S. You can see on here that this is a 4-inch screen size. and that the resolution of that screen is 480 by 800. And it's listed as density HDPI. The reason I use this one is because it's the one with one of the smallest screen sizes, which makes it really, really good for testing, because it makes it really good for testing that it's going to work on even the smaller screen sizes, which makes it easier to see, okay, if it works on S, it should work on everything else. The other side of things is because the screen size is small, it actually uses less resources when it's emulating. So it's actually also one of the faster devices to emulate. So that's why I use that as my main go-to. So I'm going to pick Nexus S. And you're going to go to this next screen. Okay. Now, you'll see on my screen that Q and R look a little bit different. Okay. That's because I've already downloaded both of those API platforms. If you see a download button on R, go ahead and click it and start the download for R. Okay. That will take a few minutes. Let me know when that's completed. Same thing for Josh and Aaron. When you get that download for R pulled down, or whether it's installed or not, go ahead and tell me when that happens. So this download, and a number of people are going through it. This download's about 600 megabytes, so it may take some time to get R pulled down. I'm glad we got a few installed, because that way at least the bandwidth is freed up for everybody who isn't. We're all trying to download. I wish there was an easy way to do things while that download was ongoing, but there's not really much we can do until that is done.
Right. Which one? Which other one? So we make sure that one has two. Which other one? Not the one. What's on that? So there's something to finish? Yep. Okay, good. You can see how it's the API 30, our stuff with XSS, but finish and not. So, and hit next. You see it's so hit next and finish on that one. Good. So, I'm going to click next on mine here. You'll notice in the top there's kind of a space to name it. So mine is named. I'm just taking the default NexusS API 30. You can see it's R. You can see it's Nexus S. If I wanted to change my mind, I could change it at this point. You can also change the starting rotation. So if you want to start by testing in landscape versus portrait, you can change that here. But those are the things I want to set up. I'm actually going to uncheck while I'm here. Don't worry if this is not something you unchecked earlier. I'm going to uncheck the device frame because I find that on my machine it runs faster without the frame. So I'm going to go ahead and hit finish.
What does that mean?
There.
It's a like border around.
It's the
something?
border around it that looks like, let me turn it back on. I'll show you what it looks like. Edit. I'll turn it back on. I'll show you what it looks like. I usually find it better if I turn it off. So I'm going to go here. I'm going to hit run. So that's a little triangle that's there, a little play button. And that should open up this, right? So you see the edges around this? That's the device frame. The part that makes it look like an Android smartphone, that's the actual frame.
Oh,
It's worth mentioning that these hardware buttons down here on the Nexus S don't work. So the back, etc., those only work with older versions of Android. They don't work in Android 12.
it's starting at your phone.
So go ahead and boot this up because we'll need one of these running in order to test together. But yeah, that's that outer part is the device frame. Yep. Okay. All right. So hit OK on that. So that is something we'll have to troubleshoot afterwards. So it's something we will have to likely go into the BIOS to change. But I can't really troubleshoot that right this way. So. Assuming you have that up and running, though, you're going to see this. Okay. What I typically do is I keep that running and don't close it. I'm going to stick that off to the side because what I can do now is I can, from the top, from this drop down, I can pick that Nexus S and I can hit the run here, run app, and that's going to run the application on that emulator.
Interesting.
There. There you go. There it is. So once it boots up and runs, you should see this on the emulator. Keep it up.
Oh, you only keep it up there? I thought you said to press it here.
Keep it up, but go ahead and press there. The best thing to do, the best workflow to go through is to keep the emulator up at all times.
Okay.
And that way you don't have to wait for it to boot back up. Because sometimes it takes a while for it to boot back up. So you got that one. Yeah, you see the progress. Sometimes it takes it. Just so everybody's on the point. Sometimes these things are sporadic, so it's very possible it just happens once and it never. And it's already started. I got sporadic issues. So there's an issue with it when you troubleshoot that. Have you changed anything in class yet? Do you have to play the class? So I'll play with you and you and Zach and get that sorted out.
I had a problem. Two
Yes.
problems actually.
Yep.
This one and this one.
Okay, so this is something that was in the instructions that you still need to do. This one, oh, and it actually is related to your moving into another folder. So your other folder is not in that.
Well, I started a new project.
So
when you
what we want to do,
I just quit it and started a new
what we want to do is we want to make sure that the simulator is running first before you get going with the application. And so now it's actually started up. There it goes.
Oh, that's it.
Okay, so you're starting to get a kind of a feel for the workflow, right? So Android Studio is our main thing. We're going to be writing in a mix of XML and a mix of Java. And we're going to use these emulators as one way to test. Okay. Now, you also have some physical devices that I've given you for you to test with. What I want you to do is pull those devices out. Plug the USB cables. You're going to plug the micro USB cable into the tablet, and the other USB end you're going to plug into your laptop. So go ahead and get those plugged into your computers. This won't work for you yet. You have to go through the install instructions. You can watch for some of them. So I would recommend just looking over data server for the minute so you can just see what's going on. Because right now it won't recognize you. So you're plugged in. Alright. So you turn the screen on, make sure it's powered on. Yeah, it's safe for like update these devices. Yes. So update your devices, don't update Android Studio. Yeah. Let's say update the device. So we have this up and running. Let's just start it out. So once it gets to the point where it's booted, okay, once the point that it gets where it's booted and it's turned on and connected, don't do the update right now. If you look in Android Studio, look at that drop down where we just looked for emulators. Okay. There should be another option in there, which is your tab. Okay. Gotta make sure that it's on. So it's not appearing. So let's unplug and try to plug it again. Because if everything's working, you should see a Samsung tablet in that drawing. Okay. If you're not seeing the Samsung tablet, I'll try to. You see this here? You want to see this on here as well? When you see that, hit always allow, so you don't see it again, because it's very easy to miss. Very easy to accidentally dismiss, and then when you get it, it's so when I hit always allow, that's going to say, hey, you have permission to talk to me, and that should mean that they're going to start. So hopefully, there it goes. There you see how it popped in. And so then it's as simple as once it pops in, you just go and you'll run on the physical device instead of running on the. So it's just like running on the. Except that it can sometimes be faster.
Yeah, I got mine right there.
Yep, so you're going to click on that, click it, and hit run.
Yeah, I already pressed OK, but I did it before it worked. So.
Okay. So we're going to run on that. And for the drivers and everything out here, then.
There it is. There she is.
So you see there? Yeah, so it's working. See when they go Gradle. Yeah, it takes a bit of a time sometimes. You just have to push it. So, on your you get connected. Go back and connect when you're ready to yes. So, you should be able to. Is the device showing up in that dropdown? Okay. So unplug the device. Okay, plug it back in. There should be a prompt that appears. There. So we'll say always, and that's it. So once you given it that permission, that really gives it permission. There it is. There's the Samsung S7T90. So you see that's popping up here. So we previously run it on the Nexus S. We're going to run it on the Samsung camera, just like we did with the other. You just said, yeah, it failed. Okay. See if we can. So that's successful. Okay. There goes. There we go. Sometimes I have to try twice. Sometimes it's flaky. Okay. So you saw basically once you've got it set up, once you've gone through this set up, it should be set up. You run it and make sure you're talking. Awesome, great. So yeah, that's great. So that's all we need. Okay, so we've got the process down. We can see, basically this drop down is going to be how you're going to choose between virtual devices or real devices. And other than that, we're going to hit that run key to start it. Now, you might notice right now that my run button has changed. Does everybody see that? So rather than just a green arrow, it's changed to a different icon. So what this one has changed to is the stop and run icon. So this will stop the app as it is currently executing and completely restart it and push a new version on. So that is the way to get to a clean build. There's another one here called imply changes. This is helpful sometimes for debugging. What it'll try to do is just push the changes that you just made and try to restart the activity instead of completely restarting the app. So if you're making small changes, sometimes that can be faster from your development perspective. It doesn't work all the time. And I wish I had a hard and fast rule of when it works and when it doesn't. But those both buttons are helpful, right? And if you can kind of figure out, like, oh, this kind of change works for the automatic, the restart, then absolutely use it. But if you really want to be safe and know that your changes are actually working, oftentimes I find myself doing the stop and restart thing.
So I would recommend kind of using this first until you get kind of a handle on it, and then you can maybe go over to the second button. Okay, so that's the gist of it. I mean, that is most of what you need to understand in terms of working with Android Studio. We do want to play around with kind of customizing this app and playing around with it. So let me check though that I've covered everything. So we looked at the minimum SDK. We chose the activity template. We did exploring around the project. We used the project pane a little bit. There's some more stuff in there. We looked at the Gradle files, layout files. I think there's some more stuff in the reading material, more than what I talked about, so definitely make sure to check that out. And they do talk about the editor, manifest, app icon. Okay, I do want to mention that. So when I look at the device, if I go back, and use this little toolbar to go back and look under the apps that are installed, you should see here, there is the app I have installed, Hello World. So that's the icon and the name of it. You might notice it's getting cut off a bit in the drawer. I can drag it in here and still. So you'll notice that there's a very small limit for how long your name can be, right? Even Hello World doesn't fit.
Your stream on Discord changed for some reason.
Did it? I'm not sure why, because I just told it to.
Maybe it's because you're running that emulator and you haven't chosen that. I see your.
I told it to share the whole entire screen, so I don't know why it keeps switching on me there, but I told it to share the entire screen. Yeah, okay. So, label resources. One thing you might want to pay attention to in terms of the name. So if I look under the manifest, the application, as I said, kind of gives us information about the app as a whole. There are two settings in here that you might want to look at. So the Android icon, that's the icon that we use for the launcher. And what's listed here as the Android label is the name of the application. So what you can see on mine is that the label points to the string app name, right? So anytime you see this at is pointing to, hey, the value here is not actually here, it's somewhere else, right? So this is actually saying, hey, there's a string called application name, which is the application name. So if I wanted to change the name of the application, I need to go down to strings and change it here, right? So if I change this to test and then run it again, what we're going to see is that has changed, as I said, the name of the application. So test will be here up on the top, and it will also be here on the icon. So the icon is now named, the application is named test instead of named Hello World, right? So you can go change the name there should you need to. Boop, boop. See what else is next. The application theme. We'll talk about theming later, but as you can see in the manifest, you can see that it's specified here as using theme Hello World, right? So that's specifying a theme for the entire application. What else we got here? This has changed a bit. It used to be that in the manifest we specified the minimum and maximum versions that are app supported. So here they've got the Mint SDK version, the Target SDK version. That's no longer set there. That's strictly in the Gradle files. Originally we didn't have Gradle files, and so that's part of why they were there. Build process. We looked at those. I'm just trying to see if there's anything I really need to
make a note of. You will see that there's a section regarding dependencies. Dependencies are those things that our application is built on top of or needs. So for instance, if you remember when we were doing stuff with Node or React, you'll remember that in the package.json that there was a list of dependencies and things we could install from NPM. It's the same idea here. So under build Gradle, these dependencies are really the same idea. So where it says implementation, it's saying it depends on these other packages, these other things that have been written by somebody else. Now, it's on a package registry. It's not on the Node package registry because this is not Node code. This is not JavaScript code. It's Java code. So these dependencies actually live inside of what we call Maven repositories. Okay, so they're actually under Maven repositories, but we're pulling them down with Gradle. So that means the way that they're deployed, the way the people that are hosting it with a technology called Maven. That's the name of the repository, but we're actually using Gradle, and it's a slightly different syntax to pull it down. Okay, so sometimes you'll see for certain packages, you may see some XML files. That's Maven versus this sort of line is that. So we can get additional dependencies and other things that other people have written this way. So we just look at how to run it on a virtual device and a physical device. Okay, so let's look at logging, right? So when we go to run our apps, oftentimes, we may need to debug what's going on there and figure out what's happening. Okay. From third semester, remember that we spent a lot of our time looking at logs, right? We used logs and we used the debug package a lot to kind of figure out what was going with the back end of our server. So we're going to do the same idea here. In Android, you can use logging. Okay, you can use logging, and then we can read those logs from Android Studio. That gives us access to see a lot of things that may or may not be visible on screen. We can kind of debug and test what's going on as the code runs. So, writing logs is pretty easy. I'm going to hit enter here, add this after the set content view. All right, log dot, okay. So log, that's the main logging class in Android. It's worth mentioning, the examples that you saw with Mosh were using system.out.printstream. We never use system.out.printstream on Android, period. We always use the log class instead, okay? So we're using the log class instead of system.out.printstream. Okay, so under log, you'll see that there's a bunch of different methods, okay? There's an I method, there's an E method, there's a V method, D method, etc. These stand for several different levels of debugging. So I'm going to step out here a second and talk about what those levels are. So when we talk about debugging, we've got verbose, we've got debug, we've got info, we've got warn, we've got error, and then I believe there's also a fatal layer as well. Okay. The level that you log at is a way of saying how severe is this of a problem or how important is this information. If you're logging something as fatal, that's saying, hey, this is immediately going to cause the app to crash. We have to fix this. Oftentimes, things that are logged as fatal are things like, I'm out of memory, or I have a stack overrun and I can't go any further. So fatals generally cause the application to crash. Error means something went wrong, but I may or may not be able to deal with it. Generally speaking, error would be just a simple exception. Like, hey, I tried to read this file, but I couldn't. Something went wrong with reading this file. I tried to make an HTTP request to the backend, and the backend didn't respond, or there's no internet because there's no internet connection. Warning would be, okay, there's something wrong. It might not be wrong. It might just be fine, but maybe you should check it out, right? So warning is an indication to the developer that, hey, pay attention to me. Next up is info. Info means there's nothing wrong. Everything's behaving as it should be. But here's some information about what's happening, right? So oftentimes we might log some very short info messages to just see how the user is flowing through the application. So like I might, after they logged in, I might say they logged in. After they go to the shopping cart, I might log shopping cart, etc. I might log some very short informational messages just as they're taking different actions, so I can look at that log and see, okay, they did this, and that caused the crash. So those log guys are really helpful for figuring out where the bug is, right? What screen is it on? What line of code is maybe the trigger? What happened before then? They did this and this and this. So it's to give you some context. Next up is, on the lower level, is debug and verbose. Okay, both debug and verbose are things that you should never ship to your client. Your customer should never be logging debug and verbose methods on their device. It's just a waste of their battery, if they are. Okay, so debug are messages you put in temporarily to diagnose a problem. Okay, you put them in as you're troubleshooting. Once you're done troubleshooting, you take them out. Same thing with verbose. Verbose is a way to put some messages in while you're testing, then you have to remember to take them out. It's worth mentioning all of these layers, regardless of what they are. If you ship it to production, if you put it on your user's device, it will still be logging that, even though they're not connected to Android Studio. All of the apps that you have on your smartphone are logging messages. They are constantly logging messages. That does cause battery life. It does cause, actually, oftentimes those are written to disk, so it can also cause disk strain. Make sure you really reduce how much you're logging before you ship it. Cool. But that's a thing to do with. So those are the different ones. Okay. And so the way we specify what level it should be logged out at is by which method we call. So if I say log.I, that's going to log at the info level. Okay. If I said log.d, that would be at the debug level. Log.w would be at the warning level. E would be at error, etc., etc., etc. So that is just the first letter of the level. So don't disregard that one character. That one character is probably the most important thing in this slide. The most important decision that you choose when you're writing logging is what level should it be logged at. Okay. That is the most important decision to make. Now, log here for me is showing up in red because it didn't include the import. So if I hover over it, you may see that it says cannot resolve symbol log. I can actually hover over here and hit import class. That will add the import. So once I've done that, there should be an import at the top that says Android util log, because this is part of Android. Okay, part of the Android utilities. So log_i, and then log_i takes two arguments. First, it takes a tag, and then it takes a message. So what I'm going to do here is I'm going to log as the first thing. I'm going to log hello world, or hello. I'm just going to log hello as the tag, and then I'm going to log is my message. Okay, so log.i, hello, my message. So that first string, as you can kind of see, is when I finished it, it put in these tag colon and the message colon. I didn't type that myself. It just added that. Okay. Before we start this running, on the bottom, you'll see that there is a Logcat tab. I'm going to pull that up. Okay. So Logcat is where we see all the messages that the device is spitting out. Okay. When I pulled this up, you'll see it's filtered down to my application, but it's showing anything that is verbose or higher. Okay. So it's going to show a lot of messages. So what I'm going to do is I'm going to hit run. It's going to restart the application. Terminate yes. You saw the spam coming through. All right. It's going to run. And eventually the application is going to start up, which it did. Okay. Now, here's a challenge. I told it to write out my message. It's somewhere buried in all this text. How do I find it? Well, I can scan with my eyes until I find it, which is right here in the middle of the screen. You can see on the left is the tag. So the I/ represents informational. That's the level. Hello is the tag. And then my message is the actual content of the message. So that's where it occurs. Oftentimes, this can be so noisy that it's really hard to find the messages. Like this is a lot of noise, right? And we have basically not written any code yet. Right? So what we want to do is we want to limit the levels that we're looking at. So I'm going to filter this down to just informational, right? So if I filter down to just informational, that's going to cut out any debug and any verbose messages. Okay. Now, unfortunately, there's a bunch of warnings in here. I can't, unfortunately, do much about that other than go hide. Okay. But you'll notice this filter, it says, I only want messages that are this level or higher. So I can go, for instance, to error, and it will only show me the things that are errors or higher. So if I wanted to really push this, I'd make this a log E and say, hey, something really bad is going on here. Let's restart the app. And now it's going to be in red because it's there. So that's one of those reasons why you want to make sure you get the level right. Because oftentimes I will go filter down to just errors looking for the problems, right? Oftentimes I'll just say, okay, let's just filter down to errors. I just want to see any places where your app is misbehaving, and then we'll track it down from there. Otherwise, there's just too much noise, right? So that means really, anytime you have an error, anytime something goes wrong, do make sure you log that as E. If you just have informational stuff, just log that as I. Okay? So that's how we can start to debug things. Now, oftentimes the convention for the tag can really be anything. Okay? So the tag can really be any string you want it to be. Okay? The convention among most Android developers is they use a particular thing as the tag. Okay? What the thing that most people use as the tag is the class that it's in. So generally speaking here, because this is in main activity, I would generally spell the tag out as main activity and use that as my tag. That helps me track down to where in the code potentially triggered that message, because again, you can see that occurs here. So the convention is that usually the tag is the activity name. But it doesn't have to be. Sometimes what I've done is I've had the tag be the subsystem, right? What system is it in part of my application? Because sometimes it's easier to filter down by subsystem than it is to filter down by really knowing what class it's going to be in. Cool? Questions? Yeah. As I said, you don't type those things out. Don't type in tag. Don't type in tag. Don't type in message. Those are not valid syntax. So they're not actually there, right? Like the tag and the message that are appearing on my screen are not actually in the code. IntelliJ is just adding it. It's telling me I'm passing this as the tag and I'm passing it as the message, but that is not actually there in my code. Yeah. 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 It's just magically there. Okay. And it'll do that pretty much anytime you call a function. It will tell you what parameters you're passing it as. Okay. So we've looked at how to do some logging. We've looked at how to start our applications. Let's look at how to use the designer a little bit. So I'm going to go back to the layout, activity main. And I'm going to start playing around with this. Now, originally when I started developing Android applications, what I learned was actually that it was easiest to design UIs actually directly editing the XML. That used to be the case when primarily we were working with two different layout containers, namely linear layouts and relative layouts. Those are honestly a lot easier to code through the XML and a lot harder to use the designer for. Nowadays, the designer is actually really good. I don't actually look at the code very often. I actually usually just use the drag and drop designer today over using the code, and I would really stress that you probably want to do the same most of the time. Because most of the time you're better off using the designer than using this code editor most of the time. Okay, so let's go back to design, and I'm going to show you how I play around with this. So I'm going to zoom in a little bit. You may notice that I have two different views, okay? One that's showing up in white and one that's showing up in blue, okay? This one is called the preview mode, and it tries to be as close as it can to what it's going to be on the device, okay? It's not always correct. Don't trust it. There's a lot of times where this will show something different than how it actually looks on the device. But we'll try to be as close as it can, okay? The one on the right is the blueprint mode, and what it does is it just shows you the bounds of all the components that you have on your screen. Okay? It just shows you where the edges and the constraints are. Okay? Now remember, we're working in a constraint layout. Okay? Constraint layout is honestly awesome. I love constraint layout. I wish it was available in the web technologies framework. But it's a bear to get your head around. Okay, it is not like anything you've used before. Okay, so there's a reason that it works the way it does, but it is kind of awkward. So if I click on this text view in the center, you'll see these lines projecting out. Okay, these four lines are the constraints. Those lines are the constraints. Okay, the way the constraint layout positions elements is using constraints. Not using like, hey, this is a child of this, not as this is a parent of this. It doesn't use ancestry, and it doesn't use like the way you might think, hey, it's X number of pixels from the edge. It's not margin and padding, and it's not ancestry. It's something totally different. Okay? So constraint, you can think of it like a spring. This has got 4 springs, and we can change how those springs behave. Right? And so if we don't include a spring, it's just kind of floating out there. There's no constraint. There's no bounds to it. But once we add a constraint to it, that gives it some limitations to where it can be on screen. Does that make sense? So right now, we've got 2 springs on the left and right. They're both basically pulling with equal force, which means that the thing's in the middle. Same way with top and bottom. We've got one spring pulling down and one spring pulling it up. Same force, it's in the middle. That's what we use. Okay, and that's actually, this is the layout that we're going to use for most things in this course. Okay, so definitely get intimately familiar with it. It's going to take some time. I'll work with you, but it's going to take some time to get there to make it jive and make it make sense. Okay. So let's start with this. I'm going to go up here. I'm going to show you a button. So there's a little squiggly here with a red X. It says clear all constraints. Did everybody see that? I'm going to click that. It's going to say, are you sure you want to do this? Because this is going to delete all of the constraints in the entire layout. Yes. All right, so I've just deleted all of the constraints in the entire layout. My controls are not constrained, right? There's no bounds. This can be anywhere, right? Which means if I were to run this application right now, Android wouldn't necessarily know where to put those widgets, right? And in most of the times, it ends up putting them in the top left corner, but that's not guaranteed, okay? So one of the requirements from the constraint layout is that every single widget on the screen, every single component has to be constrained. Has to be constrained. It has to be constrained horizontally, and it has to be constrained vertically. Okay, has to be constrained horizontally and has to be constrained vertically. Take a note of that. Okay. Now, what I mean by constrained horizontally, that means it has to have at least one constraint on the left or right side of it. It can be both or one or the other, but it has to be at least one of those. Similarly with top and bottom vertically, it has to either have a constraint on the top or a constraint on the bottom. It doesn't have to have both, but it needs to have one or the other. Cool. So that means that every component on your screen always going to have 2 to 4 constraints. That's it. 2 to 4 constraints. Never any more, never any less. Okay, so let's say we want to make a very simple form. So I'm going to delete this. And let's say we want a form that has 2 inputs. Okay? So what's a simple form that we can make that's got 2 inputs?
Login.
Huh?
Login.
Login. Okay, let's do that. So let's go for a login screen. So I'm going to go over on the right. The right side is my palette. That's kind of my where I can grab widgets from. So I'm going to grab in a text view as a label. I'm going to grab in another text view as another label. I'm going to go over to, right now I'm under common. I'm going to go down to text. And I'm going to get an email here, an email text view. I'm going to put that on top. I'm going to grab a password field. I'm going to put that down here. Okay. So I've got 4 widgets now on my screen. 2 of them are input boxes. We call those edit texts. And 2 of those are labels. We call those text views. Okay. So let's see what happens if I run this application. Terminate, yes. That's kind of ugly. See what happened? Because they're unconstrained, all 4 of my controls appear in the top left corner of the application. Right? I haven't constrained them. So they're just like, oh, I don't know where to go. I'm just going to go to the top left. Not what you want your user's experience to be, especially because those 2 input boxes are right on top of each other. So it doesn't work well. So what I need to do is I need to constrain them, okay? And so usually I try to do it this way. I try to kind of go from the top left corner or one of the corners and work my way down towards the opposite corner. So I'm going to start with the top left corner and work my way down to the bottom right until everything is constrained. Now, to give myself a little bit more space, I'm going to turn this blueprint view off. So I'm going to go to the drop down here, which looks like a blue stack. And I'm going to go just to the design surface. That way I just have this. Okay. So, and maybe... So yeah, maybe I'll do this in Blueprint because we're working with constraints. Yeah, Blueprint's a little bit easier here. Okay, so I'm going to start with the text view on the top. I'm going to constrain it to the top and the left. And I'm going to constrain this under here and to the left. Okay, Now, notice one thing that's happening. See all the components are right up next to each other? Everybody see that? When I connected them, they just all smushed together, which isn't really what I want. I want some spacing between them. Now, up on the left, there is this dropdown. Looks like 0dp. If you click on there, that is your default margin. So your default margin always starts at 0 if you don't change it. I always have to remember to come in and change it because I don't want 0 as my default. I want 8 as my default. So 8dp is what you usually want to use here. So I'm going to pick 8. That way, if I go further from this, it's going to automatically add a margin of 8 instead of a margin of 0. Now, I can fix the constraints that I've already added, which I'm going to show you how to do. So I'm going to pick the text view at the top left. And over here on the right, under the layout pane, I'm going to change both of these to 8 and 8. And I'm going to do the same thing for the edit text, 8 and 8. That way they're pulled down a bit. That way there's some spacing between the edge of the screen and adjacent components. And you can see that delineated as dashed lines. Cool. All right, so I'm going to connect the other ones. So we're going to connect the text view up here. I'm going to connect it down to the left. I'm going to connect this to the bottom of that text view and the left side of the screen. And there we go. And so this time, because I have my default set to 8, I didn't have to go manually change all the margins again. Right? It just automatically added the margins as I was adding constraints. Now, if we run the program right now, let's see what this looks like. There we go. We got a start, right? We got something, right? So appearing vertically, and they're over here all left and left. Now, some things you might notice is, for instance, that this isn't really taking advantage of all the width that's available there, right? So, like, there's actually some extra white space over here that I could utilize, right? So I might want to utilize that. I generally did, right? I generally want to have these text views extend and cover the entire width of the text. Everybody good with that? Okay. So this is fine. This is what you're going to get if you only put the constraints on one side. Okay. So what I want to do is actually put the constraints on both sides. So back here, I'm going to say show all constraints here a minute. And I'm going to constrain this to the right. 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 So I've constrained each of them to the right. Okay. It looks like they're all centered, which they are, right? Now that they're constrained to the left and right, they're centered on the screen. Okay. That gets me to another layout. Right? So if I wanted it to just be all left aligned and not make use of the space on the right, I could do the first one. Here I'm going to have everything centered in the middle, but it's still not going to take advantage of all the available space. Okay? So that's your starting points, right? So your starting point is you're going to start with this kind of centered layout. Okay. Now I'm going to show you how to take this and expand it, right? So one thing to be aware of, constraint layout sometimes works a little bit like Flexbox. It's not really Flexbox, and you really do have to think about it differently. But this is one of those things that's kind of like FlexGrow. Okay, so there's a setting that's kind of like FlexGrow. What I can do is I can click on these elements, and over on the right, there's a few ways to get to this, but usually I do it from over here.
you'll see that there's that box, right? You see there's the box, there's margins on the outside, and then there's a box. There's 4 arrows within there. Okay, so the arrows going horizontally are going to change its horizontal behavior. The arrows going vertically are going to change its vertical behavior. Okay, the vertical behavior and the horizontal behavior right now is both set to wrap content. You can see that in the drop down that's down here. Wrap content says only take up the space that you need, no more than that. The minimum space that you need, and otherwise just say that size. Okay, what I want to do is I want to change this to match constraint or 0dp. Actually, I want to keep the height as wrap content. I just want to change the width to 0dp. As soon as I change the width to match constraint, it stretches it out. See it? It stretches it out. So it stretches it out to fill the full space that it's constrained to. That's how I get it to be the full width of the screen. Okay. So I'm going to take all 4 of these. I'm going to highlight them, and I'm going to change their width to match constraint. That's going to get me a layout like this. Okay. Now that their widths are all match constraint, that's going to work here. And it's worth mentioning that by using this match constraint, it's always the width of the device, even if the width of the device is bigger or smaller. No matter what size the device is, I'm not fixing it to a specific device size. I'm just saying be as wide as the device is. Okay. Now, things you might notice that the text and all these things have gone all the way to the edge because, as it turned out, when I constrained it to both sides, it got rid of my margin. So I do need to go back in and give it some margin of 8 on the left and right. I need to go back in and count that. Other things you might notice is it's left aligned, all of these different fields. So like the labels are left aligned and the text fields are left aligned. So I may want to go in and maybe center the text within those individual labels. I'm going to show you how to do that here in a minute. But let's fix the margin first. So from the margin perspective, I'm going to select all 4 of them, holding Control. So I'm going to hold Control to select them all. And I can't change their margins all at once. Yeah, I have to change their margins one by one. So I'm going to go here, 8 on the left, 8 on the right, 8 on the left, 8 on the right, 8 on the left, 8 on the right, 8 on the left, 8 on the right. Okay, so those are pushed in. Okay, so now I'm going to go to that label on top, and we're going to go find the alignment for it. So on here, there's a bunch of alignments, things that are visible in terms of settings that you can change. On the top, bottom, you'll find that there's a section called All Attributes. Oftentimes, we may have to go look in there. Oh, there it is. So under Text Appearance, you have to expand it down here. I can go to this Align Center. So I'm going to align center there. I'm going to do that the same way with all of these so that these texts are going to be centered aligned. Okay, so that's a starting point for getting something designed here. And if we start the application, when I start typing, you'll see that it appears all of those are now centered. Okay. Now, next question. Let's say that we've got the text here. We've kind of left placeholder text in there. You see how it says text view? I want to actually say password, email, and password. So I need to actually change that text. The way I change that text is I'm going to click on the component. And if you look here, you'll see that there's two things. There's an ID up here. That ID up at the top is what we actually use in code to refer to it. And down further is the text that's appearing. Now, you'll see that there's two text fields here. Does everybody see that under common attributes? There's two texts. One has a wrench and the other one doesn't. Okay, so anytime you see this wrench, the wrench says this applies only in the designer and not at runtime. Only in the designer and not at runtime. So what I want to do for these labels is I want to change the actual text, right? So I want it to actually always say email, not just in the designer. So I need to change that top down. So email. Why is my caps lock? There it goes. Email. So I'm going to set that to email. That's going to be a text there. I'm going to leave the designer version empty because I want it to be the same as when it's running. And I'm going to go down to the other field and make this password. So now I've got email and password. Okay, I'm going to go back to the designer view. We can kind of see how this looks right now. So I've got an email, I've got password label, I've got a field for it, I've got another field here. Okay. Now with the fields are a little bit of a different story. So with the fields, they have both of these text fields again. But oftentimes I want the text that appears in the designer to be different than the text when the application runs. So when the application runs, I want that field to be blank, but I want some text to be there in the designer so I can test it. So oftentimes I'll leave that first one blank here. I will fill in a value on the designer, so the one with the wrench, and I might say John.doe at example.com or something of that sort, right? So that way that value will be there in the designer. I can test it, and I might want to show a password, same way here, and that is in that wrench section. So when I'm looking at it in the designer, you're going to see an email password as if it was typed in. But if I actually go run the application, both of those fields will be blank, which is what I want. Okay. You don't want that for a few of the lab assignments, a few of the projects. Cool? Is everybody good with that? Oftentimes that's really helpful to know what the fields represent. Because otherwise it's like, well, this field doesn't have any text in it, it's blank, I don't really know what's going on here. But I also don't want that text to just appear when the application runs. So it's a really, really helpful feature. Okay. Let's see. What else do I need to do? We probably also want to add a button while I'm here. So I'm going to go back up to Common, add in a button. I'm going to anchor that to the bottom and the left and right. So that's going to be nice and centered. And maybe we change the text on that button. Where is it? Text. Login. There we go. So we have, pretty quickly, we've built up a login script. Okay. Doesn't look like much yet, but it's a start. Other things you'll want to do as you're designing and laying out the UIs. Okay. Does everybody see the component tree on the left? Does everybody see the component tree on the left? The component tree is kind of showing you how it is architected, how it is structured in the XML. That part is really important to pay attention to because it affects how you write your code. Okay. Now, if you're looking at the component tree, notice that all of my components don't really have very good names, right? You see I've got text view 2, edit text, blah, 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 another edit text, and a button.
right? I need to give those good descriptive names. Another gotcha, and one really big gotcha in the world of Android, is these IDs, so the names of your components, actually have to be unique within the entire application. Not just within that screen, they have to be unique within the entire app. That's a hard ask. Okay, so what do I usually do? I usually preface it with the name of the screen. To make sure that it's different between every screen, oftentimes the name of the component does include the name of the screen we're on. So which screen are we on?
Main activity.
We're on main activity, right? So I need to include main in there. So I might call this top one, I might call this something like main email label, right? Now, as soon as I change it, it's going to ask me, hey, you're changing the ID of a component. I'm going to have to go refactor some code because that name is used in a few different places. Okay. This is a good reason to make sure that you get those names right early. Because if you're changing this later, and especially if you're using the same ID on multiple layouts, this is going to cause a lot of problems. Okay, so this is where we really want to make sure that we do this early. So refactor, it's going to fix it. Okay, next up, the second field. This is the main password label. Yep. And this top one is main email input. Yep. Refactor. This one is main password input. And this one may be main login button.
Can you explain again why we need to do this early?
So, because these names are gonna appear throughout your code, right? So these IDs that you have, they appear in the lab. They're used for all the constraints that you set up. All the constraints you set up include that ID, okay? And so we just actually refactor all of the constraints as we were changing those names. Those IDs also occur in our Java code. We'll also be using those IDs in the Java code. Everybody clear with that?
Yeah.
So we're referring to these.
It's just like C# .NET.
Yeah, and the same idea. Same idea with Windows Forms. You need to make sure you name all your components. So that's good. All right, we can run it just to make sure that it's still up and running and there's no problems there, and mine's working just fine. And I think that may be where we leave it today, right? So we've seen kind of the intro of how you work with the layouts, and maybe tomorrow we can look at how do we start to respond to the click event or other things and make code that responds to what's going on screen. Cool. Okay. That's what we got. I would ask for tonight, if you have not yet, definitely read through under perusal. You're going to read through lessons 1.0 and lessons 1.1. Kind of what we talked about today. So read through those tonight, and then tomorrow we'll pick back up with lesson 1.1.